The Goldilocks Zone, where the interesting stuff happens. After definitions and examples, we'll look at the vital role of the Goldilocks zone in adaptive learning in each of the three streams, in a cell, the flow channel, and in optimizing the mode of learning. The Goldilocks zone refers to a donut-shaped region of space which is just right to sustain life, hence the name from the Three Bears story. But when we look more closely, it's not merely the location which makes the difference. Outside of Mars' orbit, water freezes. Inside of Venus' orbit, it vaporizes. A balance of dynamics exists, optimal conditions for life, where liquid water flows. Examples of similar processes can help generate a better definition. In sports, the stretch zone; in academics, the growth zone; agriculture, Satoyama; and in language acquisition, the zone of proximal development and the I+1. The just right region is pervasive in nature. Between the 20th parallels, atmospheric conditions are just right for typhoon formation. The oceanic conditions are just right for coral germination and growth. Satoyama is a chaotic region where agriculture co-adapts with the wild forest. Proximity or duration of exposure to the trigger establish the Goldilocks zone in desensitization therapy. A coach knows which challenges are just right to stretch an athlete's ability. When anxiety is poised between comfort and panic, conditions are optimized for adapting to novel challenges. The same principle prevails in adaptive learning. Incrementing the challenge enables the learner to identify the Goldilocks zone and to adapt learning strategies. Examples of this include Krashen's I+1, or comprehensible input, as well as the zone of proximal development from Vygotsky and Bruner's role of scaffolding. Now let's try a broader definition: a dynamic which is sensitive to initial conditions where complexity is just right to sustain adaptation. This is closely analogous with the just right region between stable and unstable of complexity, where opposing feedback loops maintain a dynamic equilibrium. The complexity of a task is set for the Goldilocks zone of those students within the first standard deviation. What to do about the others? Reduce the challenge for the same task for the left wing and increase the challenge for the right wing. Fine-tune the task by reducing the quantity or quality of relevant parameters. With each challenge, learners explore the edge of chaos just enough to adapt learning strategies, stabilize usage, increase fluency, expand the Goldilocks zone, and prepare for the next challenge. Like a virus in a petri dish, a series of adaptive tasks pushes the edge of chaos to encompass more of the learning landscape. Learners ascend the flow channel through this series of adaptations, improving not only their language, but their ability to learn language as their learning skill co-adapts. This is meta-learning. Here's a sample lesson. Students rotate, taking one of these four roles, listed in order of complexity. Begin the lesson with left wing students in role 1 or 2, right wing learners in the 4 position, and the mainstream learners in the customer position. Each position prepares them for the next up the hierarchy. Roles 1 and 2 are naturally tuned lower as they require no verbal output. The waiter position is naturally tuned higher as it requires both input, output, and decision making. In Ritzy restaurant, the easiest task is the watcher and chef. It can be easier if we reduce the menu options. The customer role can be increased by imposing price limits or diet restrictions. Yet another application for the Goldilocks zone is at the cell level. Establishing a synergy of the cell requires synchronizing of the 3 streams. Understanding the optimal conditions for synchrony as a Goldilocks zone frames the process as adaptive rather than cumulative. The responsibility for synchronizing the task finally depends on the learners, period. Although the teacher brings all the components to bear. The learner participates actively in a co-adaptive process rather than merely as a passive recipient of information. Thank you for your kind attention. A shout out to the Complexity Learning Lab at Systems Innovations and to Santa Fe Institute for Complexity Science.